Good morning friends and good morning ma'am. I am C.Harish of 2nd BSc Mathematics here to take a seminar about in a subject called numerical method, and the given topic for me is to solve the system of equation by using Gauss-Jacobi and Gauss-Seidel method. Before going to the sum, let me explain what do you mean by Gauss-Jacobi and Gauss-Seidel. Gauss-Jacobi and Gauss-Seidel are followed by iterative methods, not as an regular matrix method. So what will be the difference between the regular matrix method and these two methods? Regular matrix methods will give you an answer in a whole number, which may be 1, 2, 3 or 10. But the as Gauss-Jacobi and Gauss-Seidel are the method is used to give you a precise answer, that is in decimal form. If you get the answer in 1 in a matrix method, you can get 1.567. It will be a precise answer as compared to the matrix method. So these are the main uses of Gauss-Jacobi and Gauss-Seidel method. So let us see about what is the use it in our day-to-day life. The major use of these methods are used in parliamentary, because government cannot give a huge budget system in a precise method without using the concept of matrix. Okay, let's now move on to the basic problem which is given to us. So the given sum is it is in a linear equation form. 10x minus 5y minus 2z equal to 3 is the first equation. 4x minus 10y plus 3z is equal to minus 3 is the second equation. X plus 6y plus 10z equal to minus 3 is the third equation. So let us solve this sum by using Gauss-Jacobi at first. So using Gauss-Jacobi method. So these are the given matrix in the equation form. Let us write it in a matrix form. A is equal to 10 minus 5 minus 2, 4 minus 10 plus 3, 1, 6 and 10. So the first conditions we must check, does this diagonal matrix satisfies the Gauss-Jacobian method. So what is the given condition? The given condition is nothing but the diagonal matrix must be greater than sum of the other two elements in the same row, in the same matrix. For example, the diagonal matrix of first row is modulus of 10, so it must be greater than minus 5 and in modulus plus greater than minus 2. So obviously 7 is lesser than 10, so we can say that the given above row in the first row is the x diagonal is greater than other two elements in the same row. So same followed in the next y and z rows. So 10 is greater than 4 plus greater than 3, and 10 is greater than 1 plus 6. We take modulus because we need a absolute answer, not an equal answer. So we take modulus in this given matrix. So it confirms that the given matrix obeys the Gauss-Jacobian method. So the next thing is we must separate the equations of x, y and z in the three given respective equations. So x is equal to 1 by 10, 3 plus 5y plus 2z will be given in the first equation, and y is equal to 1 by 10, 3 plus 3z plus 4x, and z equal to 1 by 10 minus 3, and it's minus 6 minus 6y. So the given conditions we have taken it. So the first condition, first satisfaction or condition must be we must give the values for the x, y, z, initial values. So it's the initial iteration, and we give the values as x, y, z equal to 0, 0, 0. So, and using this we find the x1, that's the initial iteration value. So 1 by 10, 3 plus 5 into 0 plus 2 into 0, so that is equal to 0.3. and y2 y1, it's y1, initial iteration of y, 1 by 10 into 3 plus 3 into 0 plus 4 into 0 equal to 0.3, and z1 is equal to 1 by 10 minus 3 minus 0 minus 6 into 0, and we get the values as 0.3. So these are the values for x, y, x1, initial iteration of x, y and z, 0.3, 0.3 and 0.3. So we found the initial iteration value, that's first iteration, x is equal to 0.3, y is equal to 0.3 and z equal to 0.3. Now substituting these values in the second iteration, it means the same equation we are finding the second iteration value through substituting these x, y and z values. So x2 gives 1 by 10 of 3 plus 5 into 0.3 plus 2 into 0.3 is equal to 0.39. We get the answer as same. So y2 equal to 1 by 10 of 3 plus 3 into 0.3 plus 4 into 0.3, and we get the answer as 0.33. So next z2. So z2 is equal to 1 by 10 minus 3 minus 0.3 minus 6 into 0.3 is equal to minus 0.51. So x and equal to 0.39 and y equal to 0.33 and z equal to minus 0.51 are the values for the second iteration. So using these values we find the third iteration. So same process is continued until we get the answer. So we can see the third iteration values. x3 1 by 10, 3 plus 5 into 0.33 plus 2 into minus 0.51 equal to 0.363. So as this method is time consuming, I have found the iterations values for x3. From x3 I have started. x3 equal to 3 plus 5 and 0.363 and y3 equal to 0.303 and z3 equal to minus 0.537, and using these values I have substituted and I have found x4, y4 and z4, that is fourth iteration, 0.3441, 0.2841 and minus 0.5185. And same, using the same method I have substituted for x5 and I have found the values of fifth iteration, that is 0.2841, 0.3441, 0.2841 minus 0.5181, and I have found the iteration values. And for the, constantly sixth iteration and seventh iteration I have found, this is seventh iteration values, 0.342, y7 equal to 0.285 and z7 equal to minus 0.505, and we have found for 8th iteration using same value, and x10 equal to 0.342, 0.285 and z8 equal to minus 0.505. so let us we can come to a conclusion that these two iterations give the same values, so these must be the equal and precise answer for the given matrix, as x7 is 0.342 and x8 is 0.342 and y7 is 0.285 and y8 is 0.285 and z7 equal to minus 0.505 and z8 equal to minus 0.505. So x equal to 0.342, y equal to 0.285 and z equal to minus 0.505 are the answers for the given matrix. This is precise answer as compared to normal matrix. Okay, let's now move on to Gauss-Seidel method. So now we are moving on to Gauss-Seidel method. So the procedure is all same as compared to Gauss-Jacobian. We are checking out the diagonal values and we have known that those diagonal values are greater than to their respective elements, and we are finding x is equal to some equation, y separating y equation and z equation. The only change occurs in its initial iteration. What is that change? We have given the values for Gauss-Jacobian as x equal to 0, y equal to 0 and z equal to 0. But in this case, we do not substitute the values for x. We just substitute values for y, which is equal to 0 and z equal to 0 at its initial iteration. The only changes difference between Gauss-Seidel and Gauss-Jacobian. Using this, we are finding the initial iteration value. So x is equal to 1 by 10 3 plus 0 equal to 0.3 and y is equal to minus 1 by 10 into minus 3 minus 4 into 0.3 and minus 3 into 0 equal to 0.42. So and z equal to 1 by 10 into minus 3 minus 0.3 minus 6 into 0.42, which gives us minus 0.582. So we have found the values for x, y and z, but the thing is we are using Gauss-Seidel, so the procedure must be same. For first iteration we are just using y and z values. So y is equal to 0.42 and z equal to minus 0.582. So x1 value will be 1 by 10 of 3 plus 5 into 0.42 plus 2 into minus 0.582, which is equal to 0.3936, and y1 equal to 1 by 10 of minus 3 minus 4 into 0.3936 minus 3 into minus 0.582, which gives us 0.2824, and z1 is equal to 1 by 10 minus 3 minus 0.396 minus 6 into 0.2828, which gives us 0.50906. So as this problems take so much time, it couldn't be explained as fast. So I have solved this sum and I found the iterations values for second iteration 0.39, 0.28313 and 0.50384, and substituting y and z values I get third iteration value 0.34085, 0.28517 and minus 0.50518, and fourth iteration so same, I'm substituting the y and z values, so I get 0.3415, 0.2850, 0.5052, and in fifth iteration I'm substituting the values of y and z values we obtained in fourth iteration, and I am getting 0.3415, 0.2850 and minus 0.5052. As we comparing the values of 4th iteration, 5th iteration, the values are same and it's precise. So we can come to conclusions that x is equal and x, y, z values we have found, and x is equal to 0.3415, y is equal to 0.2850, and z equal to minus 0.5052. But as compared to Gauss jacobian, Gauss seidal gives us precise value, and we get the answers precise as compared to matrices also. So thank you for giving me this opportunity to explain about both the concepts of Gauss seidal and Gauss jacobian using matrix method. And thank you, it completes my presentation, and thank you for listening to my presentation. Thank you.